Friday. I can't be there today, so I decided to do a little video. You can watch it the first time and then pause and replay it and take notes, or pause and discuss. Please keep it real. Ask questions to each other, help each other out. So we're still talking about solving absolute value equations. So absolute value is a math way of saying distance from zero. So as soon as you see absolute value, you're thinking of distance from zero. So there's two locations that have the same distance from zero. If you're talking about a distance of 4, then there's two places, 2 points that have a distance of 4. 4, and then also 4 units this way, 4 spaces this way, you end up at -4. So there's two locations with the same distance. So absolute value is distance, and then distance, we know there's two solutions, two. So it's not just one solution. So keep that in mind. So if we look at this example, this is more simple than this one. We're going to start with this one. We started with something similar on Friday, and then we're going to build to something like this and then even harder. So with this one, we're solving now for x. We're saying what value will make this equation true. So if x was 5, then that would be saying the absolute value of 5 is equal to 5. So that means the distance from 5 to 0. The distance from 5 to 0, that distance is 5. So that's true. So x equals 5 is a solution. But that's not the only solution. If x was equal to -5, then that's saying the distance from -5 to 0. So if you're here at -5, the distance from here back to here, and that distance is 5. So that's also true. So x could be 5, and x could also be -5. So with absolute value equations, we have two solutions. So you can pause that, discuss, refresh if anyone was absent, and then once you're ready to move on, press play. Okay, so with this example, now it's a little bit more complicated, but if we don't really worry about what's inside the absolute value bars, we know that it's distance because we see the bars. We know we're looking for a x value that will make this true, but we don't worry right now just about what's inside here. We know that the distance that we're talking about is 5. So if all of this was equal to 5, if all of this was 5, then we would have the absolute value of 5, and that would be true. If all of that was 5, the distance from 5 to 0 is 5, that would be true. Or if all of this was equal to -5, then that would also be true. The distance from -5 to 0 is also 5. So we're going to set that equal. We're going to say, okay, if all of this was 5, so we're going to say x plus 3 equals 5. All of that, if that was 5, we're creating an equation. If all of that was equal to 5, and we just did it right here. And then we're also going to say if all of that was equal to -5, that would be true. So we say a different equation. X plus 3 is equal to -5. So now we have two different equations. The x plus 3 part, we're not changing. So here we have two cases. We have a positive case, +5, and we have a negative case, -5. The x plus 3 doesn't change. Now that we have two different equations, when we solve, we're going to have two different solutions. So x equals 5 minus 3, 2, and then -3 minus 3, bills and bills, that's -8. So these are the two solutions that would make this equation true. Some people solve, they get 2, and they think that the other solution is -2. That's in a simple example. You had 5 and -5, but it's not always the case. So if I were to plug in 2 back in, if x was 2, x equals 2, 2 plus 3 is 5. The distance from 5 to 0 equals 5. if I were to plug in -8 back in, -8 plus 3, I got more bills, so that would be -5. The distance from -5 to 0, the distance is +5. So that would be true. These are the two solutions that make this original equation true. So talk about it, press pause. If you want to replay it, write it down. But remember that you have to make two separate equations. A lot of people see this problem and they just do this. And they treat it like a regular equation. But you can't do that. It's an absolute value problem, distance problem. With distance, you think of two solutions. Distance from 0, there's two places that have the same distance from 0. So two solutions, so we have to have two cases, two different equations to get those solutions. So you can't just solve and get one solution. You have to make two cases. Your positive case, your negative case. The x plus 3 isn't changing. It's just equal +5 or equals -5. So rewind it, replay it, talk about it, help each other out. And then we're going to do another example. When you're ready to move on, press play. Okay, this example is, I would say, a medium. Those ones were a little bit easier. The difference between this problem and the last problem is that the last problem looks all messy. The last problem was the absolute value of x plus 3 equals 5. So in the room, there was no other numbers in the room with the absolute value. In this one, we have a -7, so it's not a simple absolute value problem. So we want to make it more simple like that one. So we want to get rid of this -7. So we want to eliminate the other numbers and get the absolute value bars alone. So if we could get rid of that -7, then the absolute value would be alone. So the opposite of subtraction, because it's being subtracted, is addition. So we add 7. 5 plus 7 is 12. So now we have the absolute value bars alone. Now that they're alone, we're going to make our two cases. This is a distance problem. Absolute value is distance. Distance, there are two locations with the same distance. Here, the distance that we're talking about is 12. So there's two places that are 12, that have a distance of 12. So either all of this could be 12, the absolute value of 12. The distance from 12 to 0 is 12. So all of that could be 12. X plus 3 equals 12. Or all of that could be -12. The distance from -12 to 0 is also 12. So x plus 3 equals -12. So we have our two different equations. So once the absolute value bars are alone, you're making your two cases. Your positive case and your negative case. X plus 3, x plus 3. The inside part, you don't change that. It's just, it could either equal 12 or it could equal -12. So we subtract 3, x equals 9. Subtract 3, bills and more bills, that's -15. You owe someone 12, you owe someone else 3. You owe a total of 15. So these are the two solutions. If you were to plug them back in, they would make your equation true. Okay, so talk about it, press pause if you have to, and then replay it, write it down. Take notes on this. You should be taking notes on this to have something to refer to. Okay, and then once you're ready to move on, we're going to do one more example that's a little bit more difficult. So press play when you're ready. Okay, so this example, there's more going on. It has the -7 and it has a 2. So now there's multiple numbers. So the 2 is like that closest with the absolute value bars. So that would be the best friend. Best friends go last. So we get rid of him first. So add 7, add 7. We have 12 right here. And then we have the absolute value of x plus 3. And then we still have this 2 here. So the absolute value bars aren't alone yet. We want to get rid of the 2. A lot of people subtract 2 minus 2. Think that they're getting rid of it. But I like to put a little dot right here to remind myself it's 2 times. It's not 2 plus, otherwise I'd see a plus sign. Not 2 minus, I'd see a minus sign. When I don't see anything, it's 2 times. So I want to undo the multiplication. The opposite of multiplication is division. So whatever I do to one side, I do to the other. I divided, so I'm going to divide here. 12 divided by 2 is 6. Now I have the absolute value bars alone. So here I'm going to make my 2 cases because here the distance that I'm talking about now, it's the distance is 6. So I could visualize that. The distance from 0. There's a distance that's 6. 0 to what is 6? 0 to 6 is 6. Or 0 to negative 6 is also 6. So this is the distance we're talking about. So all of this could be 6. I need to scoot this over. All of that could be 6. The absolute value of 6 is 6. Or all of that could be negative 6. The distance from negative 6 to 0 is 6. So we have our 2 different equations, so we'll be able to get our 2 different solutions. Subtract 3, x equals 3. Subtract 3. Bills and bills, be careful right here. A lot of people say negative and negative become positive. That's only if you're multiplying and dividing. We're not multiplying and dividing. So that's negative 9. Bills and bills. So here are 2 solutions for this inequality. So talk about this one, replay it, rewind it, pause it if you need to. Help each other out, stay focused, have a productive day. And then I'm going to put up some examples for you guys for classwork. See you later.